All right, so here's the type B for this question. What is the chloride ion concentration after the reaction described above is complete? Okay, so we're going to be looking for the chloride ion concentration. So, and that is going to be after the reaction is complete. Okay, so finding that chloride ion concentration, and remember our square brackets mean molarity. So we're looking for the molarity of those chloride ions. We need to look for a source of our chloride ions. Well, and again, this is after the reaction is complete. We can see that sodium chloride is going to be in aqueous solution, so it's going to be a source of our chloride ions. So first, let's find the chloride ion concentration in sodium chloride, or what's going to be produced. Again, since we have our limiting reactant, he is going to be the boss, and that's always what we start every other calculation with. So I have 0.0100 moles of my limiting reactant, which is sodium hydroxide. And I'm going to take that to moles of sodium chloride. So for every 2 moles of sodium hydroxide, I have 2 moles of sodium chloride formed. Now, I don't really want sodium chloride, I want chloride ions. And because I'm dealing with molarity, moles is fine if I can just get it to moles of chloride ions. So I'm just going to keep going with this one. And I'm going to say, well, in every mole of sodium chloride, there's 1 mole of chloride ions. And that's because there's only 1 chlorine in sodium chloride formula unit. So now when I do this, I find that there are 0.0100 moles of chloride ions in that solution. But again, they want molarity, not just moles. So now I need to divide by my volume. This is just another little trick here. Remember, this is after the reaction is complete. So you must imagine this reaction. We have taken 2 solutions, each of 100 milliliters, and we have poured one into the other to produce this precipitate and our sodium chloride. So now I don't have 100 milliliters, I have 200 milliliters. All right, so I need to divide because this is after it's been mixed by my total volume. And in this case, it's going to be 0.200 liters because I just add those 2 volumes together. And so with that one, I'm going to end up with 0.01 divided by 0.2, and I end up with 0.05 molar chloride ions from NaCl. That's my source there. But that's not my only source. There is another source of chloride ions, and that would be the magnesium chloride. And you might be saying, well, wait a minute, I thought magnesium chloride, that was a reactant. It is. It's our excess reactant. So our limiting reactant, our sodium hydroxide, has been all used up. This is my excess reactant. So there's still some of this floating around. So it is another source of our chloride ions. So then we have to figure out how much excess reactant we have, and then we can get our chloride ions from there. So again, you're going to start with your limiting reactant, 0.1 moles of sodium hydroxide. We're concerned about the excess reactant, so that's where we're going to go. So for every 2 moles of sodium hydroxide, I have 1 mole of magnesium chloride. Now I have it to magnesium chloride, and this will be the amount of magnesium chloride used. And so that's going to be 0.005 moles of MgCl2 used. That's not how much is left over. That's how much it's going to take to react with this much sodium hydroxide. So now I have to figure out how much remains. At the beginning, for my sodium or for my magnesium chloride, I had 0.01 moles. So I'll say 0.01 moles is how much I had, minus how much I used, which I just calculated as 0.005. Oops. And that equals, that's supposed to be an equal sign, 0.005 moles remain. It just happened to be the same number as before, but it's not always going to be that way. So now we know how many moles of magnesium chloride remain. Still not, I need to get back to how many chloride ions or what its concentration is from this source. So at this point, I'm going to say 0.005 moles of magnesium chloride remain. And for every 1 mole of magnesium chloride, I'm going to take this to magnesium ions, I have 2 moles of chloride ions because there are 2 chlorines in magnesium. That is going to give me 0.01 moles of chloride ions from the magnesium chloride that remain. Again, that's moles, not molarity, so I need to divide by that total volume again, which we found before right here at 0.20000 liters, because we added the 2 volumes together that were given to us. That's 200 milliliters. And so we get 0.05 molar chloride ion from magnesium chloride. From that source. Well, these are our 2 sources of chloride ions. And so all we really have to do is add those together. And so 0.05 plus 0.05 is going to be 0.100 molar chloride ions total. And that would be your final answer.
May I have your attention, please, for the following students listed in the office: Lauren Coley, Marisol Martinez, please come to the office. Lauren Coley and Marisol Martinez, please come to the office.